All right, people, this is the last video. This is Mastery Study Guide Topic 22, Graphing and Solving a System of a Quadratic Function and Linear Function. So we did this on our graphing calculators a while ago, but we can also, another mastery topic is graphing a quadratic in standard form or in vertex form. So example 1, we have a quadratic in vertex form. Example 2, we have a quadratic in standard form. So we're going to look for the intersection points. So we'll start with example 1, where we have y equals x squared minus 4. So if we look at what the transformations are, our parent function is y equals x squared. So the only thing is we're shifting down 4, and that's it. So we can go ahead and plot that vertex. And then there's no scaling or flip, so over 1, up 1. Over 2 up 4, and I'm going to go over 3 up 9 just because I have enough room. So we can connect that with my beautiful parabola. My next equation is a line. We have a y-intercept of 2 and a slope of 1, so rise 1, run 1. So I'm going to plot as many as I can, and I can already see where the intersection points are. There are 2, one at -2, 0, and one at 3, 5. We can always plug these back into both of the original 2 to make sure they work. Our second example is going to take a little bit more time because our first quadratic is in standard form. So we have to use our axis of symmetry formula, x equals -b over 2a, to find the x value of the vertex, and then plug that back in for every x so we can get the corresponding y of the vertex. So our b value is +4 and our a value is +1. So -4 divided by +2, we get an x value of -2. Then we need to plug that in every time we see an x to get the corresponding y. -2 squared is +4, 4 times -2 is -8, plus 3, blah, blah, blah. Then we end up with a y value of -1. Therefore, our vertex is at -2, -1. So we can go ahead and plot that. Next, we look at our a value, which is 1, so that means there is no scaling. It doesn't flip, we don't have to change the distance, it's going to follow the normal parent function pattern. So there's no scaling. Over 1 up 1, over 2 up 4, and that's as much room as we have. So now let's graph the other line. 2x plus 6, y-intercept of 6, and a slope of 2. It does go off the graph a bit, but it does intersect twice. So those 2 points are -3, 0 and 1, 8. If we had extended our parabola up a little bit, it would have intersected nicely at 1, 8. And there's both of our solutions. Again, you can check both of these by plugging in the points. You can also solve these algebraically. So if we look at the first one, they're both equal to y, so that means they can be equal to each other. So we do x squared minus 4 equals x plus 2. Get everything to the left. X squared minus x minus 6 equals 0. I'm not going to do this out, but then you would factor and solve for the x's and then get the corresponding y's by plugging it back in. You would do the same exact thing for example 2. So we can solve them algebraically and graphically because we know how to solve quadratic equations and we know how to graph with transformations. That is the last of the videos. I hope you have a great day.